by introducing our first set of speakers. So we have Matthew Morris. Hello, Matthew. From Confluent. Then we have Steve Howard from Confluent as well. Matthew, how long have you been with Confluent now?
I joined in June of last year.
So you're fairly new, but Confluent is one of those sweetheart technologies. We know that it's new, but in the open source world, it's been there for a while now. So it is notorious for being a well-used product in the open source world, and it has long roots, of course, coming from LinkedIn. And then you have Steve Howard. Steve, are you there?
I am here. It's good to be on with you guys this evening.
That's great. So Steve, you're a solution architect at Confluent, and you have deep technical expertise. How long have you been with Confluent now?
It has been just over a year. It was March 4th of last year is when I joined. It's been a fun ride, great journey actually.
So with the modern stack like Confluent, this is dog years, right? So 1 year is equal to 10 years, right? So you've been a decade.
That's actually very true.
So we have a few more folks over here. I want to introduce Mr. Elliot Church. He's my co-organizer in many things that we do together, starting with Big Data Ignite, the meetups that we do of data science and analytics, West Michigan, the West Michigan Cloud Computing Meetup, and the IoT West Michigan Meetup. Hello, Elliot.
Hello, Tuheen. It's good to see you face to face.
Fair enough. And then we have Amway Corporation being represented by Jeff Bosch. How are you doing, Jeff?
I'm doing well. Thanks, Tween.
I understand, Jeff, that you may have a little bit of a bandwidth problem, so you may be doing mostly work through audio, and that's okay. It's coming through pretty clear. And then you have Sanjay. Hi, Sanjay.
Hey.
Hey, Sanjay. So Sanjay has been there is working with, actually both Jeff and Sanjay have been with Amway North America for, I don't know, at least 2 decades or more combined.
Yeah.
Maybe probably. Okay. So you've gone through all sorts of different, what an evolution of technologies mean for a company like Amway for a pretty long period of time. So without further ado, I'd want to hand this over to Matthew Morris. Matthew, why don't you say a few words about Confluent, and then we'll switch it over to Steve Howard to talk about today's presentation about Confluent and how we do ETL on that platform.
Yeah, thanks, Tween. Welcome everybody. Matthew Morris. So I'm a enterprise account executive. I'm based here in Grand Rapids, and that means that I cover enterprise accounts throughout Michigan. And I've been with Confluent since June of this year. And what we've seen here in Michigan since Steve and I started covering the territory in June of last year is a lot of momentum in the Apache Kafka space here. It's been interesting because it seems that when Steve and I go out and see customers and prospects, that a lot of folks have been using the open source product for various timeframes and various scenarios, whether it's dev or pre-prod and even production. And we're learning some things too about the platform. But I think the nice thing is now that there's a company that's been in business for a little over 5 years, Confluent has, and it was founded by the creators of Apache Kafka out of LinkedIn. So they left LinkedIn and founded Confluent to support Apache Kafka as a commercial software product. And we quickly moved to cloud and have Confluent Cloud. It's a managed cloud service. It can be fully managed or you can self-manage it. So that means either you can run it on the cloud provider of your choice, or you can have us run it for you on the cloud provider of your choice. So that kind of flexibility is something we're seeing more and more in demand from our customers, and the roadmaps to transition to cloud so the enterprise can take advantage of workloads that are business use cases that are running in cloud. Confluent is an enabler of that. With the managed offering, it really simplifies the infrastructure piece and for our customers, so they can focus on developing the IP around the business cases and the business use cases. So I really look forward to Steve's presentation, how he's going to showcase some of the capabilities and what Confluent has brought to the table from an engineering standpoint and innovation standpoint, with additional products and offerings that sit on top of Apache Kafka that our customers are asking us for, and are also in the trenches with us, helping develop and add features to products as we continue to see the business grow. So thanks again for hosting us, and I'm going to let Steve go ahead and kick it off and go into his presentation and demo.
Hey, yeah, thanks, Matthew. I appreciate it. Let me go ahead and screen share. And while I'm getting that working, I always like to take the opportunity to thank everyone that commits time to watch something like this, because I know all of us would like to be with our families in the evening, with our friends. And so it's always encouraging to me that people take the time to invest in themselves for this kind of thing. I know we were initially supposed to meet at, my understanding was BW3. And of course, circumstances of which everyone's aware has prevented us from doing that. But if you'd like, have a chicken wing on me. Let's go ahead and get started. As both Tuhin and talk to you a little bit this evening about Apache Kafka, and specifically how it relates to what ETL looks like and data transfer if you have on-premise environment that perhaps you're managing and you're looking to make a move to the cloud. We'll talk about each of those components. So why cloud? So everyone that probably would devote the time to a talk like this is probably aware of these, but we'll run through them just to set the background. Advantages of cloud, cost savings, strategic edge. You can implement apps very, very quickly, especially SaaS type services, even one like Confluent provides, but even outside of that, something like Workday, MongoDB, very, very quick to implement. Most of these, again, I won't belabor them much. Reliability, of course, you have far more of that in the cloud, given the fact that you can have multiple availability zones, multiple hardware footprints, load balancers, just redundancy everywhere that's been hard historically to implement in a single data center for which you may have been responsible. Unlimited storage, collaboration, quick deployment. That's a huge thing. I mean, largely you can get even a service like Confluent stood up in probably about 10 minutes. If you'd like to start working with Kafka, there are similar services from MongoDB, DataStax, those kinds of things. So large reason that organizations are moving to the cloud. Recent survey that I just happened to find on this says that 22% of organizations are public cloud only. I would define these as cloud native. So you might think of companies like Lyft, Uber, Airbnb that probably have little to perhaps no hardware footprint that is managed outside of a public cloud provider, Microsoft or Google or anything like that. The other 3%, I thought this was interesting, are I actually did this journey about 8 years ago with VMware. We tried to stand up a private cloud. I don't say we tried to. We actually had some success of that journey. But regardless, 69%, a little over 2/3 of organizations are what we would call hybrid. And that's who we'd really like to talk about this evening, because as you can see statistically, you're probably more than likely in that group in which you do have an on-premise footprint that you're managing with perhaps legacy applications, perhaps newer applications. And you're also maybe fully moving towards cloud, or perhaps you're in your first or second deployment, or perhaps you're looking at doing it over the next 12 to 18 months. I think you'll find something relevant regardless of where you are on that journey as we work through this evening. So there's some risk with doing this, right? There's this bridge to cloud is a term sometimes you'll hear. And, when you take that step out, it's like I heard someone say one time, what comes with the cloud? Don't you rain? And obviously there are, as we've talked about, there are a lot of advantages to going to cloud, but there's also some risk. You have tried and true systems. I come out of the retail world. I spent about 7 years running enterprise architecture for Express, the apparel retailer. We had several core merchandising type systems that were incredibly important to our business. To up and just pick those up and move those to the cloud would have incurred a lot of risk. So normally most organizations find themselves with a need to move to cloud, but they have to be very, very aware of the risk they're taking in doing so. So what is Kafka and how does that fit? So I like to usually describe this as publish and subscribe reimagined. If you've ever used a JMS type system like IBM MQ or RabbitMQ or ActiveMQ, anything like that, traditionally you have a very, very smart broker. One of the systems I built when I was at Express was an enterprise service bus. And we did that with Apache Service Mix, which uses ActiveMQ for the broker. The broker is actually responsible for removing messages that have been consumed by a given consumer, for delivering messages to subscribers. Apache Kafka is different the way it does it. It is a distributed commit log. And what that means is the consumers that are reading the data out of Kafka are responsible for keeping track of where they are. And that buys you a lot of things. The data, for one thing, is immutable. You can't change it. I like to usually refer to this, especially within the context of the commit log and the immutability. If you picture something like an Apache web server access log, if you've ever tailed one of those, you'll just see requests. You'll see an IP address, a URL, a response code, a method, the timestamp, all these different things. You never go back and change one of those that occurred, 30 lines up. It's just constantly being appended to. That's kind of the way Kafka works. What that means is data can be retained indefinitely. Unlike usually I shouldn't say usually, anytime in a JMS standard system, when you consume a message, the message is gone. If you decide you need to go back and get it, it's already been consumed, it's gone. Kafka kind of stands that on its head where you control what you read and when, and the only thing to which you're subject is how long your Kafka cluster administrator has decided to retain the data. So what makes it different? So again, it's a persistent log, which can be kept, reread, kept indefinitely. It's a distributed system. So the Apache Service Mix implementation that we did was that you could make the brokers highly available, but there was a lot more work to it. Apache Kafka out of the box will, if you have 3 brokers, it will automatically basically stripe your data across those 3 brokers is how you can think of it. If the leader broker happens to fail, the other 2 that have a copy of that data immediately step up and start serving those messages to consumers. Runs as a cluster. You can expand or contract it elastically. So as you find you have a need, you stand up 3 or 5 brokers, and all of a sudden, wow, we're pulling all of our data for our enterprise through this platform. You can say, you know what, we need actually 7 brokers now. You can easily provision those as well as restripe your data across all of them so that it's evenly distributed. And again, the 3 copies is the replication of that data internally within the cluster for fault tolerance and high availability. And this is a big one. So it allows real-time stream processing. We'll actually see an example of that shortly. Really what that means is the data, if in your mind, if you can picture a system in which you have source systems on the left, you have Kafka in the middle, and you have destination systems on the right. Like a canonical example is like your operational data stores, like orders, customers, products, all of these kinds of stores. Perhaps you're consuming messages from those systems into Kafka. You are enriching them with real-time stream processing. You're operating on the data that is within Kafka in the middle of that picture you might have in your mind. And then perhaps you're surfacing that, now putting it to an enterprise data warehouse on the right, perhaps a dashboard or a microservice that needs to consume that enriched data, whatever it happens to be. It allows you to do that. And the big thing about that is it's not just processing a single message at a time. There's actually context associated with each and every message that passes through. Because again, you still have the history of the messages for that particular key or whatever it happens to be by which you need to group that data. allows working with data streams at a much higher level of abstraction. So rather than thinking about publish and subscribe, you can start thinking about, hey, I'd really like to have customers be joined to orders and product to determine, what they're buying and be able to give that to my Hadoop data lake to do analytics or whatever it happens to be, all in real time. So where does cloud fit into this conversation? That's where we started, right? So as you finally start making the move to cloud, even temporarily, there's a need to sync data. There may be always a need to sync data. If you have an on-premise data center and you need to transmit data to a common use case that we find is organizations that have an on-premise data center with, again, these operational data stores, whatever your business happens to be, and perhaps they need to send that data to Amazon or Microsoft or Google to be able to do analytics on it and then perhaps feed it back in again for distribution to other downstream systems. So what we'll talk about tonight is this ecosystem that allows you to use Kafka as both a source as well as a store. So again, back to that picture in your mind I asked you to construct, in which you have sources on the left and perhaps you're also syncing data on the right. You can actually also keep real data in Kafka as a store and scale. This is what they got known for. I was reading an article just this week on Monday. I was absolutely blown away by this. I have been in technology for more years than I'd like to count, to be completely honest with you. And LinkedIn is currently processing 81 million messages a second through Kafka. So your organization probably isn't anywhere near that scale, but certainly if you find that you get to the point where you are, the scale is certainly there, the ability to drive that. So the question becomes, how do you do this? So you've got this on-premise data center, and perhaps you want to sync that again to this data warehouse or analytics platform you want to do ETL on in the cloud. So what a lot of organizations find themselves doing, and this is, to be completely honest, when I was at Express, this is how we started. We started doing point-to-point between apps on-premise and in the cloud data warehouses. We were using at that time AWS, SNS, and SQS. We had SaaS services. They were all point-to-point integrations between all these different applications. Small in number, fairly easy to manage. When you get into large numbers, that quickly becomes unwieldy, cumbersome, and quite frankly, just not even doable when you get to a certain point in organization size. So what we'd like to suggest as an option is something that might make that a little bit simpler for you without losing any of the things you would come to expect, like guaranteed delivery of data, scalability, availability, and flexibility. So what we'd like to talk to you a little bit about tonight is taking in data from source systems. And I do have a database picture of the customers here on the left. This is actually going to be 2 small Java classes that we'll have for customers and orders that we'll join together. And let's just kind of walk through this diagram and see if this makes sense. So generally, your customer database is fairly static. You may have customers that log in and update their profile, perhaps products in which they're interested, or do they want to receive text messages in terms of marketing, or perhaps they move, or whatever the case happens to be. The data doesn't change that frequently. Orders tends to change, ideally, if we're successful, very frequently. So what we're going to do is watch each of those loaded into Apache Kafka in an on-premise data center. And we're going to use a tool that we provide called Replicator, which is, as we'll see, it is a Kafka Connect, very, very specific implementation that consumes from Kafka in your data center, and we'll publish that to Kafka in the cloud. For this evening, we'll be using Microsoft Azure. And another thing you can do, you have a couple of options down here, and you'll see this as we start working through the demo. KSQL is a piece that allows you to do, actually, let's just go forward to those slides. Maybe this will help. Let's start with Replicator. I'm getting ahead of myself. So Replicator, again, is a highly customized connector. All this really is if you've done any work at all with Kafka, you can picture yourself writing a consumer that subscribes to a particular topic. As it gets messages, it stores them in memory, and it turns around and it says producer.send to a second Kafka cluster. Largely functionally, that's how Replicator does it. It handles several important items for you in addition to that. It actually will propagate topic properties. So as you set things, retention windows and things like that, any topic property at all actually that you set will be propagated by Replicator. It also does offset translation. If you've done anything with Kafka, you know that what that means really is that your consumers, if they're reading in data center 1, you failed in data center 2, your consumers can then point to data center 2, Microsoft Azure in this case, and pick up where they left off. You can do single message transformations on it. So as data comes through, you might want to redact data for legal purposes. You might want to filter data, whatever it is you happen to need to do. You can rename topics, and you can prevent cyclic replication. So if you have active deployments, it actually inserts a provenance header that says, hey, this was produced in data center 1. When data center 2 gets it, it writes the message, but the replicator in data center 2 will ignore sending that back to data center 1, so you don't get into this back and forth ping pong match of the data. It only goes that first time. You can whitelist, blacklist, and regex topics, what you want to replicate if you decide that you need to do that. Some advantages largely are probably simpler operational overhead, because you only open a single network stream. You can integrate new cloud apps. Latency, the data transfer perpetually in real time. And you can perhaps save some money because you can use batching and compression. And largely, at the end of the day, right, this is the transition phase during cloud migrations. This is how you can get some of the data from your on-premise data center into the cloud. And there's potential for a DR solution component. If you're replicating all the data to the cloud and you actually have a failure in your on-premise data center, you have a secondary copy that you could look at and using for restoration or recovery, whatever it happens to be. So KSQL, this is where I said I was getting a little bit ahead of myself. So KSQL is the piece that allows you to do that stream processing with largely a SQL-based syntax. Not quite ANSI, but close. As we'll see this evening, you can do real-time processing on that. You can enrich data by joining streams from disparate source systems. We'll see tonight how you can join orders to customers based on a customer ID in real time, aggregate that, and then we won't show this evening, but we can talk about different connectors you can use to deliver that to a system like Azure Data Lake or something like that. That's where the ETL piece comes in. You can pre-stage some of that ETL if you need to deliver it to multiple destination systems. You can transform data types, flatten the data, take it out of flattened data back to a map. You can aggregate data, sum, count, things you would come to expect from a standard SQL-based language. And the connectors is the other piece of this. So when I talked about the left and right side of Kafka, these are the piece, like you can see for Azure, there are data lake storage sinks that you can use to actually write the data directly into Azure. So what you end up having is customers and orders on premise, send them through Replicator. In KSQL, perhaps you enrich those and join them, perhaps you don't. Regardless, you deliver them directly into Azure Data Lake with no additional work. Same thing with connectors. And I apologize, this is so small, but I wanted to get it on one page. And it actually kind of points out the volume of the connectors. We've spent a lot of time on this to give you some options in terms of getting data from on-premise to cloud and then into the appropriate systems in cloud. We like to present that as kind of a complete solution. So let's go ahead and take a look at a quick demo. Can everybody see this? Everybody on the call, is that coming through?
Yeah, it's good.
Good stuff. Okay. So largely what we're going to do this evening is, first of all, we've got just a couple of simple loaders. And all these are really doing, we don't need to belabor the point, but just to show you kind of how this works. This is a standard Kafka producer. So in this case, this would be something perhaps you'd see in a microservice. It's a lot of code, but it's one of these things, I put it all in one, so hopefully you kind of get the idea of what we're trying to do. All we really do is we load 20 companies in, we create a schema for it, and we load it into a local Kafka cluster, which you can see here. We're just loading this into a local cluster. You can think of this as the cluster perhaps you have in your on-premise data center. We then have a producer that will end up writing this data to our cluster in Azure. And the way it does that is with that replicator, that bridge that we had in the middle of the one slide. This will This is the software that actually consumes from our customer's topic in our local broker as well as our orders and sends those through as is. It does no transformation or anything on that, which is good. It's a byte for byte copy. That's what makes it so fast. You can run through tens of thousands and more messages per second with this kind of implementation. So almost like I was telling somebody earlier, it's like when you do a demo like this, it's for one thing, people usually say you're either insane or a genius, and usually don't know until after the demo. But we'll run through a demo. And the other thing is it's kind of like the old chef shows perhaps you watched when people cooked and they put it in the oven, and then they turned around 30 seconds later and they had this beautiful chocolate cake. It's the same kind of thing. Rather than go through the whole setup and everything with you tonight, we'll assume that we already have some of this set up. Number one, we're already running Replicator, which we can see here.
Hey, Steve, while you're doing that, so what is the meaning of factor in that properties file?
I'm sorry, Elliot, could you say one more time?
Yeah, so while you're typing there, what is the meaning of factor in that properties file? Why is everything factor 3?
Yeah, great question. So this is when I talked about the resilience, the fault tolerance that is built into Kafka. You can tell it internally. This is not replication between like your on-premise data center and the your cloud in Azure or whatever it happens to be. This is internal to the cluster. So if you can picture 3 computers sitting there, each of which have an installation of Apache Kafka installed on them, and you configure a cluster to be able to give each of them each of the host names so they know where to speak. That replication factor dictates how many copies of that message are maintained. You can make that 1 if you like, but if that one computer that happens to be hosting that topic that has that data goes down, then you would be in a data loss position.
Got it. What is offset? You referred to offset translation earlier.
Sure.
Can you explain that just a little further?
Yeah, absolutely. So when if you think about the fact that, again, I always go back to the example of the Apache web access log. So if you think about the fact that as requests, as you're clicking through and you're going through a site, and the web server's recording everything you do as an individual line, each of those messages would be assigned an offset in that log. It's the same way in Kafka.
Oh, I see.
And what the consumer uses that for, and it's a great question, it's absolutely core to how Kafka works. In most messaging systems, the consumer relies on the broker to tell it, hey, here's some data for you. You said you were interested in it. Here it is. In Kafka, the consumer actually maintains track of what he or she has read in the topic. And the way they do that is periodically as they read data, they commit, quote unquote, those offsets to an internal topic and say, hey, I've read through offset 10, through offset 20, through offset 30. All of a sudden, hey, the computer on which I was running my consumer failed. When you start back up, it goes in and starts from wherever it had left off.
So it's a way of a subscriber, so to speak, tracking their status and position.
That's exactly right. That's actually a very good, succinct description. Yep, absolutely. So let's go ahead. I'm not sure how we are on time. We've probably got about 5 or 10 minutes.
We have time.
We're good? Okay. So let's go ahead and let's load our customers. And we've actually already done this, but just so you can see these going through. So we go ahead and we magically load 10 customers, and we actually even print, Elliot, to your question, the partition to which we wrote the message as well as the offset at which it was recorded. There's really no need for us to know that. It's just kind of a nice thing to see. Maybe that solidifies the understanding a little bit more. And then we're going to start selling a lot of products. And if businesses worked like this, it would be fantastic. We're just going to let this run. And what we're doing is we're generating about 50 messages a second. It's certainly not much, but we actually put a governor in just so we could kind of watch them go by. And then we can look at this data as it accumulates in Azure. So really what we're doing at this point, and I'll refer back to the diagram. Hopefully everybody kind of got a good picture of that in their mind. So you have Kafka on the left, you have your customer system and your order system. What we're doing right now is this is the arrow that goes into that first Kafka icon we had. So we're writing those in. We could take KSQL on this side, and we'll see an example of this shortly in Azure, but we could use KSQL in our on-premise data center right here. And perhaps we would say, I don't know why we would do this, but perhaps we'd say, you know what, filter and only send the orders that have an even suffix. So anything that ends in, you can see these flying by right now, 42, 44, 46, whatever it happens to be. It's a silly filter, but you could do that. A more realistic example might be, you know, we don't want to send anything to the cloud for a customer that is no longer active. So we might get not a transaction for a customer, but perhaps an internal update. But we might see that their last purchase was 24 months ago, and we may dictate, you know what, that's an inactive customer. Perhaps we would filter on that. We could do that on premise before we send it to Azure or the cloud provider to do whatever, you know, analytics. That would be part of that ETL piece, part of the conversation, where perhaps you do some filtering here as the transactions are ready to exit your four walls before they go across the cloud. Let's go ahead and filter some of that. There may be some business value. If nothing else, you might be able to reduce some cost in terms of the publishing that you're doing into the cloud provider. So that's one way to look at it. So as our replicator runs, let's go ahead and take a look at our KSQL instance. So again, KSQL, and actually we probably could show the so these are the topics we have. These are the ones that we published. Matter of fact, if we go in here and we look at the messages, you would see new messages that would start flying by. So you can see these numbers changing as the offsets start going through. And then you can go into KSQL and you can see that we already actually have some running streams. And we'll see each of these. I'll go into a little bit more detail on each of these. So we have an orders stream that has been rekeyed by customer ID because we're going to want to join our order stream with our customer stream and they need to be joined on a common key. And down here, this might be where you do some ETL. You can see here that we create what's called a table, which is, you can think of it as very, very similar. If you haven't worked with KSQL before, you can think of this as like a table in DB2 or Oracle, if that makes sense. The only thing that's different about KSQL tables, as we'll see, you will see new changes actually popping out on the bottom. So in other words, if you said select asterisk from customer order totals in an Oracle database, you might get back, I said we had 20 customers in our simple demo, you would get 20 rows. And it would just say 20 rows processed. That would be it. As we'll see in KSQL, you'll see 20 rows processed. As new sales comes in for any one of those given consumers, you will see, or customers rather, you will see a new row be emitted with a slightly higher sales total than it was in the first 20 rows that we saw, because of course, ideally it wasn't a return, it was actually a sale. You can also—
Hey, so Steve.
Yes.
Can you go back to that KSQL statement and walk me through a little bit of the elements of it? And so let's start with the from.
Yes.
And what do those represent? Those from what I would refer to as tables.
Yeah.
They're not tables, or are they tables? What are those actually?
No, it's a great question. So a stream in KSQL is based on an underlying topic. So all of these messages that you see flying by that say sent successfully to orders in partition. This particular from here, this order stream, all that really is a stream is an abstraction on top of a topic. So a topic in Kafka is nothing but a byte array. So all that really is a computer science kind of geeky definition of something that doesn't really have semantic meaning apart from something else giving it semantic meaning. So in this case, we have a Kafka topic that has been defined with a schema associated that has things like the order ID, the quantity, the customer ID, the price, things like that. So this, if we were to say select, and we can actually do that. If we were to say select from the order string, you'll start seeing, now these are not historical, these are live transactions. And you can probably even see, this is order, almost 14,000. If we come back to our loader, you will see we're at 14,000, just a little bit over. So all of these records that we are sending to the local Kafka cluster in our data center, my laptop for clarity, that's our data center for this evening, are being replicated to Azure. And this is the select, Elliot, to your question. When we say from orders _s, that's just a naming convention I happen to choose, _s for stream. But again, this might look to the naked eye like, hey, yeah, I do that all the time in my database. But the difference is these are transactions as they're occurring, they're popping out. And the really big buy you get from that, if it were just this, that might be good to get data from on-premise to the cloud. But the real power comes in when you have something like this. As you get more transactions in here, you'll see that this has actually been running for a while where we're actually doing, this is the query, back to your question again, Elliot, for customer order totals. That's what we're selecting from here. This is being automatically maintained. So as data is coming in, as transactions are coming in, we are calculating the total sale for any given customer. And we are joining from, this is the topic that we talked about up here, where we created a stream against that orders topic, but we rekeyed it. An order stream, if you think about it, would normally be keyed by what? An order ID, right? That kind of makes sense. That's for any database people on that are watching this, it would be, that would be the primary key. So what we do is we rekey it by customer ID, because we know that down here, we're going to want to join from our customer topic as changes come in there to orders. So in order to ensure those are in the same physical partition, and this is a nuance of how Kafka divides the workload, how it literally partitions data, we rekey that order stream and then join it on customer ID. That allows us to have that common key on which we can join. So what you end up with as we go through this, you'll see these pop off the bottom, but there's a couple that just came through. But all of these orders that are coming in are constantly updating that, again, to go back to this table. So it is like a table in a database, but it's largely it's a constantly evolving table. In Kafka terms, it would be called a compacted topic, which just literally means it's still a bunch of messages for a given key, but Kafka guarantees that you will see at least the most recent value. KSQL will only expose the most recent value for a given key. So in other words, if my customer record said, I live at 123 somewhere street, and then tomorrow I move to 456 some other street, today, if you looked in the table, you would see one record for 123 some street. Tomorrow, you would see the new record for my new address. If you looked in the stream for customers, you would see both records, because that may be meaningful to you in terms of, and we talked about this briefly earlier about what an event-driven architecture is. As those events occur, you may decide it's important to react to those in the context of your business. You may want to know, oh, you know the reason that they don't shop at that store anymore? It's because they moved last week. So those kind of things, sometimes you want that granularity of data with every single change. I often like to equate it to a chess game. If you watch a game of chess and the two players set up the pieces and you go get a cup of coffee, you come back half an hour later, they perhaps made several moves. You might look at the board and say, wow, it looks to me like this person's winning because they have more pieces. But what you don't know is that for the last 10 minutes, the other person or that person that has more pieces has been moving slower and slower and appears nervous. If you had every single event that occurred for each of those players, you would have a much deeper insight into who's actually winning the game. But if you're looking to populate like a data lake, such as Azure Data Lake, it might be that something like this is sufficient. You kind of do this roll-up ETL work before it ever makes it to Azure. And then at that point, you can go back to the connectors we talked about earlier and look at which one of those is appropriate in terms of where you want to sync that data. So just to take a step back, that customer's order total table that we were looking at that was slowly growing, like you saw the rows popping out at the bottom, you might use a connector like Azure Data Lake to consume the data that's already been enriched and perhaps even aggregated into a format that this can use without it doing the work, and surface it into Azure in real time. That's a very, very common use case that we see. Other use cases are just, you have a very mature streaming mindset in your organization. You need to exchange data between applications that happen to reside on premise and in the cloud. You might decide, I'm going to replicate that data. That's pretty much what I wanted to show you. Hopefully that's useful. Yeah, that's good. So I'll turn it back over to, unless we have questions, I'll turn it back over to Tuheen.
Thank you, Steve. Thank you. And thanks, Elliot, for the questions. So this you gave a really good explanation in general terms, and also with the demo to show some of the key capabilities and even some of the newer capabilities that people might not have known about in an event log, right? Especially with the use of KSQL. And I think this sort of blurs the line about, okay, if it's an event log, you put in enough abstraction, especially with enough computing power, where you can blur the line of, okay, do you really care about what the data storage layer is behind the scenes, as long as it's meeting your needs? So good thoughts, great presentation. I think we are just a few minutes late because of me, as I was trying to figure out YouTube Live for the first time for Big Data Ignite. So as many of you might know, that this is our first inaugural YouTube Live, so a big milestone for us, and we're doing that to align with our public sector leaders of being socially distant, but virtually together. And what I wanted to do is give Elliot the floor for a few minutes to talk a little bit about Big Data Ignite and what we've been doing. Elliot?
Well, thank you, Tuheen. So I appreciate the opportunity. And let me begin by thanking those who are contributing content tonight and really being part of not only an experiment for us, but really a social experiment as we all accommodate to the social distancing phenomenon. But I'm optimistic that there's a silver lining here, and that we'll all learn a lot about how to communicate in other modalities and how to leverage other modalities. And I think it will ultimately enhance our connectivity as we return to in-person events as well, hopefully in the near future. So big thanks to Steve Howard for presenting. I think it takes some practice to get good at presenting in this online forum, because you don't get the same kind of feedback from the audience. And so it's difficult to know how your message is going over. But Steve, you managed that as well as I've seen anyone manage it so far. And so for me, you're a prototype and an example. So thanks for setting the standard there. I want to thank Matthew Morris for pulling this together in many ways. We're happy to have Matthew on the board of Big Data Ignite. He has been instrumental in moving forward a lot of initiatives, both in terms of outreach to potential beneficiaries and outreach to potential sponsors, and also kind of on the flagship for this important technology, which is Kafka and Confluent. So Matthew and Confluent have been great partners for Big Data Ignite. If anyone who is listening would like to become a partner with Big Data Ignite in fostering expertise in technologies like this in West Michigan and surrounding areas, we invite you to join us. We have lots of opportunities to contribute in a whole variety of ways that you wouldn't imagine. But if you think about how an organization runs, there's a lot of different pieces and parts and people doing logistical things and research activities, business activities. So there's plenty of opportunities. It's a great way to network with the data science and data engineering communities. in West Michigan. There's really no better way, in my opinion, than volunteering with an organization such as Big Data Ignite. You meet ambitious, exciting, dynamic, intelligent, creative, funny people. And I've just personally, just speaking from my own experience, had a marvelous time meeting people through this avenue of social involvement. With regard to the future in Big Data Ignite, we're planning for Big Data Ignite 2020. That, as you may imagine, is a bit of a moving target in the current public health situation. We've always had in-person events, and people ascribe a lot of value to getting together, and it is. It's the serendipity of meeting people who you may know or haven't yet met, but having an opportunity to converse is always great at an in-person event. We aspire to getting back to that as soon as possible, but obviously contingencies are necessary in this day and age. So we're driving very hard this year to create an online event in many ways that people can take advantage of, even if they are unable to attend in person. And so we're looking for folks who have experience or ambition to learn more about how we manage an online event and how we create compelling online content and how we give opportunities to sponsors to shine in that area. How we give opportunities to speakers to be engaging with audiences and for audiences to engage with speakers. There's a lot for us to learn, and we need all the help we can get. With that, Tuhin, I'm going to turn it back to you. Thank you.
Thank you, Elliot. As Elliot said, please reach out, and we'd be happy to connect with you. We love collaborating with you. So without much further ado, I would want to introduce Jeff Bosch. He's a manager in Amway North America. He's been through various different roles and has a lot of history in implementing various kinds of technologies. And I also want to introduce Mr. Sanjay Deshpande. He's been with Amway North America also for, I would imagine, 20 years probably. And he is also one of those good friends of mine and a very good history of going back technologies which were 20 years ago all the way now to where you're implementing event streaming architectures. So Jeff, take it away, and then we can have Sanjay present the use case that we're implementing at Amway.
Sure. Thank you very much, Tuhin and company. Appreciate the invite this evening, and looking as we work through this new way of meeting and informing each other. Thanks for everyone that's joining. Yeah, Sanjay was one of our masterminds behind moving the event-driven architecture into Amway. My key role was mainly around evangelizing upwards to our executives, providing some air cover to the team for resources and obviously funding. And so with that, I'd like to turn it over to, and Sanjay, I'll take you kind of a little bit on our journey, why we did what we did, and moving to this, and then the benefits, some of the benefits that we obtained from it.
Sure. All right. So I'll try to start presenting my self and the screen here. All right. Let me know when you guys can see the screen.
We can.
Take it, Sanjay.
Okay. All right. So thanks a lot for this opportunity. It's a great way to present what we have done and also learn from rest of the folks. Unfortunately, with the situation that we have, like Elliot said, we don't necessarily get that personal feedback. But I hope this is just a temporary phase. We would like to meet in person I definitely like to meet a lot of more people around West Michigan. And maybe we can do this again with in person when we get away from this quarantine, I guess. So that said, I'll give you a little bit background about why we shifted to event-driven architecture. And myself, Sanjay Deshpande, here's the email. Feel free to send me emails or ask questions. I'll just put this out there saying, and we'll probably spend a lot of time on this too. This is how our systems looked like before, and how they were integrated. And keep in mind, I said event-driven architecture, and we are talking about integrations, right? So I will get into the event-driven slowly, but initially it started with saying basically how we were integrated. And so essentially we had an order management system. When an order is taken, it has to send to the shipping system. There was a point-to-point integration there. We had to send an email. Okay, here there was a point-to-point integration with communication system. Customer management system, where we register. Okay, here, this is where the communication was going on. And then we had some financial reporting, business intelligence. Most of those were batch extracts, right? A traditional BI, how we were doing, either it's a daily or a hourly, whatever, but they were doing batch extract. That's how we were integrated. And there were, as we evolved, in the past 20 years that I've been with Amway, we have implemented the same thing in slightly different ways anyway, right? And which is true with every company with changing technology and stuff. So back in 2010, I think, maybe, we did a little bit of a different mechanism where we said we wanted the website, and the website was talking to the order management system. And to give a little bit background, the order management system that we had was on the AS400, which was like a mid-range or a mainframe kind of a application. And then we had the website, which was in the .NET. And the website needed order information or customer information. The order information, and we had to replicate certain things, right? And there were questions about, do we want to replicate everything? No, we don't want to. We want to replicate only certain things. So then the evolution there was we started talking about business events at that point. And it was too much of a change to put everything in the event at that point of time. So we basically said, okay, we'll just raise a simple business event and only customer management. So every time a customer is created, updated, we started raising business events, and we put only the key information. We said, raise the business event, but where do we put it? We started putting it in the queue. We had heavy usage of MQs, so we put that on the queue. There was a consumer on that queue, and we read it and sent it to a messaging messaging middleware, which was SOA Suite. And SOA Suite was taking care of sending it to 10 different systems, right? So that was the step. And there were issues with that in the sense that the SOA Suite was a heavy messaging middleware. MQs was purely on the AS400, and once you read the message, it is gone. So there was no way to replicate like a historical set of events. And so there were other means that we had to do to look at the events and things like that. So that was it. But there were other problems along with this. So let's go with it. That's one thing was, as I said, there were point-to-point integrations. It was tight coupling, and there's a lot of heavy batch processing. Changes to new systems or creating new systems were very slow because it is going to affect your other application, right? So if I had to change, go back to this, if I had to change my shipping system, that means it affects my ordering system too. If I had to change from communication, if I wanted to start sending SMS messages, again, it goes back and affects either both of these systems now. So this was the problem that it was constantly seeing. And then when we came about 3 years ago, we started a big project, which we said we want to replace our order management system and the website. And we had purchased Hybris as the way to go for the commerce. So that's when we said, you know what, we don't want to do integrations this way. So one of the things that, sorry, go ahead.
Sanjay, could you review the tight coupling problem there? And just tell me once again what that problem is.
Sure. So tight coupling is, like I said, it's my ordering management system is tied to the communication system. So there was code in order management system to say that once the order is placed, I have to call this communication system API or something and say that it should send an email, right? That means I have code in my order management system to be able to send this email, and I had to wait for processing that, right? So if something goes wrong with the communication system, my order management system is bloated with additional logic there, right? So now you have tight coupling. And if I have to change the communication management system, now I have to go back and change my order management system or customer or wherever we have communications linked, right? So that was what the tight coupling is. And I think once we go back, and I think to some extent, I think Steve talked about it a little bit, but I think he concentrated more on the KSQL or how we can do streaming. But I'm talking purely just from applications to application integration. And so that was the piece. So now let's go the next one. How they're integrated now. So what happens? The order management system is simply saying, I am going to I created an order. I just published that message on the whatever topic we want. And that's it. It's done, right? From a publisher perspective, it is done. It doesn't have to talk to any of these systems. It doesn't have to know anything about these systems, right? I am doing one thing that is taking orders and I'm done. And I say that order is created. Now, your shipping system can be listening to that particular topic and send it to whatever shipping system. That's a separate process. If that breaks, it's only that is broken, right? It doesn't affect any other applications that we have. Same thing with communication system, right? If I want to send an email, today I'm sending emails, but tomorrow I want to send SMS. I can change that. I can listen to that topic and create a separate consumer. And I can say, okay, send tweets for all you want for every order you get. That's the beauty of this, to say that, okay, I don't have to, my system is one system that I create. It does just that and does not care about anything else. I do my job, I raise that event, and that's it. I'm done.
Hey, Sanjay, I've got one question for you.
Sure.
Yeah, so what about the back propagation situation where, like, you want something, some analysis from the business intelligence system to feed back into the customer management system? How does that information get transmitted? Is it through a parallel back propagation type of system, or does it pass through the same queue in the other direction?
No, it's not coming through the same queue for sure. It will have to be a separate queue, separate topic. And because, so if you look at what Steve presented, right? So if I wanted something coming out of saying that, okay, people who placed orders greater than $1,000, I want to put them back somewhere and mark them something on the customer management system. I just put that topic. I filter that through either Kafka Connect or whatever, and then I can say, okay, just put this back on topic, saying that here's the order, but it's again more at real time. That's the key here, is you are getting that information more real time than doing batch extracts, and that is where I would say the biggest bang for the buck is of implementing something like that. So we basically, your example, I can publish it back to the particular topic, saying that orders greater than $100,000 or whatever, and then you can say again another consumer, which the line would basically go from this Kafka here back to your customer management system, saying that update their level or something like that. You could implement something like that, but you're doing this more at real time now, rather than batch and saying that. Does that make sense?
It does. Does the object in the middle represent one topic or a set of topics?
It depends. I would just say this is our event log, right? And that's why I just put Kafka as a sign. This is our event log, or the event bus, however you want to call it. And it could be, now, this does not mean it's just one topic. Sorry if I misrepresented it that way. Order management, I would publish it to a specific topic. Now, if I want to publish the same thing as order header as one topic and order line as a separate topic, be my guest, right? You can still do that too. Customers, they are separate topic. There is also a concept of keying the topic, and I think Steve again alluded to that a little bit. Is that key becomes very important because it determines what partition it goes under. So let's say I have an order. I publish that order to a topic, and then the customer comes back to the website and edits that order, right? I publish another order or event, basically saying that the order is edited. You want to ensure that that same order number comes in that specific partition, right? And that's a little bit getting into the intricacies of the topics and how they are partitioned and how you want to read, how the consumers are set up, how the consumer groups are set up. And that, if you want to go in that, I don't have the diagrams here, but that would be something it would be nice to go through as a basics of Kafka, essentially. Steve and Tuhin, I think that it might be worthwhile doing a specific meetup, just a topic for just that.
Good point.
Right. So essentially, that's made at a high level. Partitioning is for that. So you can, the sequencing is guaranteed within that partition. So if I go back and read these messages again from that topic, I will see the order was created and then order was edited. Right. So think of, I guess, I don't know what it's. You guys are the database guys. On the AS400, they used to call it as a journal. It's a what is syslog, right? Tuhin on database.
Yeah.
Right.
Yes.
So
on a Unix system would be syslog, right?
Yeah. So if you look at it from that perspective, it's essentially.
I think you meant in Oracle. I think it's the alert log. I think that's what you're talking about.
Yeah, it's basically all changes are published to that particular syslog, and then the database engine basically puts that up, aggregates that into the topic or into the table and stuff like that, right? So if you really read that particular syslog or you are really reading through a topic of all the changes that have gone through. Right? This gave us a little bit of a flexibility to say that now we want to order, once it is created and once it is changed or whatever those events are raised, there is not much that the order management system needs to. Once it is shipped, maybe something comes back and you have to update that back. Those, I haven't run this here, but I think it's there. All those transactions or all those messages are still flowing through the Kafka and coming back to the order management system. So now, I still am talking about integrations here. Now, the advantage of this going this route is also doing further streaming analysis and things like that. The problem that we had was people had a tough time getting an understanding about thinking it in those terms. So that's why we called it as an integration, because people started looking at it differently. Saying that, okay, it's just an integration means, right? This is the integration team. Or, that's how they started thinking. And then slowly now, as they have seen this, they have started getting a good, more confidence, and they're now starting to use it and saying now they're starting to think that way. But initially, it was really, we sold it as an integration tool. Now, the other piece that, again, I think Steve alluded to was why Confluent. When we chose Kafka, so what happened was I stood up Kafka in AWS and everybody was using it. But I was the only guy who knew how it was set up and how it was running. And it was running for almost a year, and we were running it in the QA and test and the POC kind of a mode. But one day, one of that AZs had issues, and I had set it up only in one AZ. And guess what? Kafka went down, right? So the question, we had always talked about it, saying, hey, if we have to set up Kafka and manage it, we need at least 3 full-time engineers to just purely manage Kafka. And we didn't want to spend people or resources on managing Kafka itself. And that's where I think Confluent came. And we were looking at what are the places where we have managed Kafka. And there were some here and there at that time. But luckily, at that time, Confluent was purely just an open source Confluent platform. But then they went out and said, okay, we are going to do this and we'll provide managed Kafka for people who want to. And initially, there was only in US east of the AWS that they were available. They said for us, that was good enough. So we went with Confluent because of that, because we don't want to worry about the management of Kafka. We just want to use it and take advantage of it, essentially. So that was basically what we have done. Then some of the things are the benefits. I think I already talked about it. Was we got decoupled. When I say true PubSub, again, a lot of PubSub middlewares that were there, like the ESBs or SOA suites and things like that, they were very heavy. They had to manage who is consuming, where they are at, and things like that, which was really a heavy. And by itself, it needed to be scaled and things like that, which again, we didn't want another additional middleware at that point. So we said Kafka is perfect. Kafka is dumb. All it does is just keeps messages. That's it. And there are no bloated applications. That is what I kind of alluded to, saying that, okay, if I have to put logic in my order management system, whether to send email, whether to send SMS and things like that, you're unnecessarily bloating applications. And then the last part being the separation of concerns, right? That way, we are separating the concerns and building applications and managing them, monitoring them much more easily. And when they break, it doesn't affect your other lines of businesses. So that's very brief. If you have any questions, you can go back to either of the diagrams.
I've got some questions. So thanks for explaining this. I think this is a great follow-up to Steve's talk, which laid out some of the basic functions and mechanisms. And so I like your focus here on an implementation and what's achieved and what the benefits are. I have a couple conceptual questions which are floating about in my mind, and it is the relationship between partitions, the event log, and topics. Could you recover that ground again? How is the event log related to partitions and partitions to topics and topics to the event log? Maybe Steve would want to chime in on that too.
Yeah, sure. Steve, you want to give it a shot?
Oh, I thought you were doing a great job. Yeah, go ahead, Steve.
Okay, so event log is just a terminology, right? And we are talking Kafka is the event log. That's just the terminology that we are we are using it mainly because from the high level architecture concept wise, when we talk about event log, we don't want to talk specifically products, right? Kafka is a product that is providing the event log. There are other ones out there. I think Yahoo has one. Maybe even Google has one. I don't know Google what they're called, but that's what we are talking about is a concept of an event log, right? So that's the reason why the event log what we're talking about. Now topics are it's like a what do I say? It actually the topic then itself they came from the JMS background really, and the queues and topics were a little bit different. Where queues were basically saying that okay, if I put a message there and if I consume it, the message is gone. A topic, the terminology is basically it's a table name or whatever you want to call it, and it's basically saying I am going to keep it for however long. And in JMS world, the topics were you can publish to the JMS topic and you can have multiple consumers, but that messaging middleware was keeping track of which consumer is read this message, and only if it has read, then I will delete. If all the consumers have read that message, then it will delete that message from the JMS topic. That's how this came up. But then I think LinkedIn took this to the next level and said that we don't care. We're just calling this a topic, but it's just basically storing each of the events, and you calling it's like a file name for all that. You should say it's a topic is like a file where it's a constantly appending events. That's all it is, right? And then comes the partitions. Now, partitions was just a way to see how better performance that we can get from the consumer side, and saying that okay, if I just put one partition and if I have 10 consumers for scaling of that particular, like say shipping system. I mean, if I have shipping system and if thousands or millions of orders are coming through, I should be able to scale it. And so that's where the partition concept came in, and saying that okay, I can push this into these different partitions, and you can even scale it to say that okay, read only from a specific partition. And I guess, Steve, was that partitioning came only because of just that, or was it even for the sequencing of the events?
Largely it was for the sequencing of events.
Okay. So that was another. The sequencing of the events was basically saying that within that particular partition, I need to guarantee the sequencing. The example that I had said, that an order comes in, order created, and the order edited should be in the same partition. So if I read that particular partition, I get all the sequence. I can reread 10 times and produce exactly the same result at the end of it.
Okay, so let me see if I understand. My guess is that the event log is physically composed of these partitions. That the partitions are physical partitions of storage that together comprise the event log. My guess is, based on description so far, is that a topic is like a logical view of this composite of partitions. I think analogously about physical versus logical expressions of a schema in a database. Do I have the right understanding of that?
I'm not sure.
I would say, yeah, that's a fair way to look at it. Like from my perspective, maybe Sanjay, if you want to add in, the topic is, if you think back to the database world and when perhaps you created partitions for a table, the partitions are the physical structures that hold the records, the messages in the case of Kafka. The table is really, I hate to use the container because that has a lot of baggage in the year 2020 in IT. But literally, you can think of it like that. The topic is really a container. And actually, if you really want to drill even farther, the partitions themselves are composed of segment files. That's the literal physical file stored on disk. The partition, to Sanjay's point, as he mentioned earlier, is largely the way that you can guarantee a message is produced. The messages for a given key are produced in order. Like the canonical example is like a bank account. So if you want to ensure that the withdrawal is processed after the deposit, your producing application would produce the deposit and the withdrawal. If those are keyed by bank account ID and transaction ID, for example, or just bank account ID, those transactions will be processed, the deposit before the withdrawal. That's the reason that you put a key on something, so it ends up in a particular partition of a topic. But the topic is largely, you can think of it, you actually said it well, it's really a logical container for the partitions of that topic.
Cool. Thanks for explaining that, gentlemen. Hey, I saw via Slack that maybe there was another question or two, but I don't see those in the Slack channel. Is there someone else?
I'll ask those questions. So there's a question from Pratap. The question is for Sanjay. Can we replay a specific message or messages that failed in a downstream application consumed from topic A? I'm guessing he's just asking for some kind of arbitrary topic.
Yes. So you definitely can replay from wherever you want, right? And then again, it comes down to the implementation of it, saying that, okay, let's say there is a shipping system consumer, and I'm reading off this particular topic A, and I consume, and there's some problem in my system that I can't process any messages. That there are ways that we have handled it, saying that, and even if you go back to the queue concept, is that there's a dead letter queue. You can put something into the dead letter queue, or you can put it as something in a specific error topic or something, saying so that I can reprocess those specific errors. If it is just that particular message had a problem, then you can do that. But if you basically stop consuming for whatever reason, you can do that way either also. So you can say that as soon as, if you're processing it sequentially, you can say, as soon as I hit this particular error, just stop it, right? If let's say if I'm processing the message and I'm calling a specific API, and I start seeing that this API, I'm getting timeouts on that API, I can just say, you can code to say that I just kill the consumer so that I don't process any more messages. You can raise alerts and say, here, now what happens there is that as soon as that happens, you can also start seeing that the specific consumer is lagging behind, right? And you can raise alerts. We have had those scenarios in some cases. And you can start the consumer, and what it does is it starts from the offset that where it left off, and it continues processing from there. There are also scenarios where we had that specific particular message had a problem. And then in those cases, what we have done is we have put that in an error topic so that I can go back and process that specific message directly from that error topic. You can also you could do it in such a way that you can put it just the offset so that your same consumer can just go back and read from that specific offset and process it. So you can do it multiple ways.
Right.
That answers the question.
Yep. And I've asked him to get back to me if he wants more details, but there's quite a few different ways to, with code you can, and with the flexibility that's offered, you can reprocess the message. There's another question. This one is from Mike Howie. His question is, how does the number of consumer groups working against the same topic affect the broker's throughput or other consumers' throughput, if any?
So I think, there's I'll take a little bit of that answer, and then maybe Steve can add more as to how they manage. There's one thing is it depends on how many brokers you have and things like that, and that's where I think you have to evaluate as you go what the throughput you want. But by and large, or what we have seen, I don't think that we have had any issues with processing how many of our consumers we have had. We have had many consumers now, like close to, this one piece alone, like for example, the Elasticsearch that I have said, is basically we have a Kafka Connect that is reading messages from here and putting it into Elasticsearch. And we have that for almost every topic that we have. And so we have that. And then there is also actually one more thing that I did not draw is we have another Kafka Connect which sends all these messages to S3, AWS S3. And we haven't had any specific issues, but how they manage it, I would let Steve answer.
I think actually that was a good answer, Sanjay. The only thing I would add is, and I on the head, there's no easy way to answer it. So for anyone else that might be watching this, the consumer groups that Mike referenced are generally the number of partitions that you have in a given topic. So if you have a topic for transactions or customers, like we did earlier, whatever it happens to be, if you define that topic with 10 partitions, that becomes your unit of scalability. So the standard best practices for your consumers, if you specify a particular parameter that's just literally called group.id, and you set that equal to my transaction processor, you can start another JVM or whatever your client language happens to be with that same group ID. And if you do that with 10 different consumers, all that are sharing the same group ID, that forms a consumer group. And that if you have 10 partitions and you create 50 application instances with group.id equals my transaction processor, 40 of them will be sitting there doing nothing. So just for some backdrop for anyone watching this, that's the design behind the consumer groups. What Mike asks is actually a really good question, because really what it gets down to, and Sanjay kind of mentioned this, is it depends on how many brokers you have. If it is normally, to Sanjay's point again, it's normally not a problem. if you had, let's pick a ridiculous number and say you had 1,000 different consumer groups going after the same topic. If that topic is distributed over all the brokers, let's say you have 5 brokers, and let's say that it's transaction ID, something that hashes fairly easily because there's a hashing algorithm Kafka uses on the producer side to decide the partition which it places. Provided that that's hashed properly, evenly distributed over 5 brokers. If you have, let's say, 10 consumer groups that are going after that same topic, it really becomes more a question of how many messages are being produced into the topic. So in other words, if you have 100 consumer groups and there's 1 message per second, it's not going to be a problem. If you have, 1 million messages per second or something like Lyft or Uber or Netflix or something like that does even more than that, it probably won't even be a problem in that case because really conceptually, each consumer group under normal circumstances is reading from the tail of the log. They're usually not, even though as we talked about earlier, you can do replayability for a topic and all of these great features, normally every consumer group that's active is going to be reading the tail of the log. And what that means is the message is probably already in the file system cache, so it's not even hitting disk to give it to you. So there's actually very little spinning disk type work that's involved with serving messages to multiple consumer groups from the same topic. So, what's the answer to that? You would really have to have a lot of consumer groups and probably an undersized cluster before you noticed it being problematic. Hopefully that makes sense. As Elliot mentioned earlier, sometimes it's hard to do these kind of virtual sessions because, as he mentioned, you don't get the feedback, but hopefully that makes sense.
No, thank you, Steve and Sanjay, for addressing that question. And, I think, Sanjay, you started with, unfortunately, that it depends requirement that you have to sort of see. But the bottom line that I've seen is that there is a lot of opportunity for tuning with hashing, with what kind of footprint that's been deployed. And Kafka has been built and evolved over time to be very, very scalable, and has been very resilient and durable and performant in real-time messaging. That's one of the big reasons why in reInvent there was a pretty big, there were a few different sessions on how Lyft has been using Kafka. And literally, if anybody uses the Lyft app, you can, the tracking of that car are individual Kafka messages as the location information is being transmitted back. So I'm pretty certain with not too much time spent, will be the impact of the consumers and the throughput can easily be resolved with different kind of architectural options which may be there.
Yep. And just to add to that, I think what happens is that, I think Matthew and Steve can attest to that, is that when we had some, like end of month, we were afraid. We generally have our end of month, we have a higher number of orders and things like that. So that's why we were a little bit concerned and we said, hey, watch this. And we really did not do any, it was literally a blip, if I'm not mistaken. And when we go over the throughput, Matthew will come after you for more money.
I have to comment on that. Depends.
Yes, it depends. Yes, that's true. It depends. I think there are other. I was just joking, but I think it's. We haven't had any issues with that, and the sizing, we have to go through that. We have to understand what kind of data we are sending. So, for example, let's touch base on that one. Is that so? Right now, we are doing only transactional messages going through this.
A quick interruption, guys. Maybe what we can do is we can turn on our cameras, or that'll help the viewers see our faces. So if you don't mind that, is that okay?
Is it my camera on? I thought it was.
So you're broadcasting the slide right now? Maybe you can switch that off.
So currently we are doing only mostly transactions, but if we do, let's say, click stream, right? That would be a lot more number of messages that are going through. Maybe in that case, we may have to scale to, instead of 3 brokers, to 5 brokers or whatever it is, right? So those are the things that we have to evaluate. And even for each topic, right? How many orders am I getting? And so that translates, or that tells me that, okay, how many partitions that I should be having for that order. And let's take an example of orders versus order lines. Obviously, orders would be lesser than the number of if I take order lines also as a separate topic. Those are the things that we'll have to think about and say that, okay, how many partitions I need, how many brokers I need. That is a constant process that you have to go through, and which is no different than any other place that you would have to, whether it's MQ or whatever it is, you still have to go through the same analysis and decide how you want to scale those.
So, thank you, Sanjay. All right, go ahead.
I was just saying, I was looking at the time, and I think we should probably begin moving toward a wind up. But right. What should we do next, doing?
So at this point, I think I'm not seeing any more questions come up. I don't see Patrick here. Any announcements, Matthew? I think we should just come to the point if there's any general announcements that need to be made, and then we can wrap this up. Matthew, do you have any Confluent announcements that you would want to make?
There's going to be a Detroit Apache Kafka meetup, online meetup next week. So I will post that in this meetup channel here in just a second, and also the online channel. So anyone who wants to attend that next week, I think it's next Thursday, feel free to join the Apache Kafka Detroit meetup.
Great. Jeff and Steve and Sanjay, any last comments before I hand it over to Elliot?
No, I just want to thank again everybody that came out this evening virtually. Like I said, it's always encouraging to me when people make that investment. So hopefully it's been useful. We enjoyed it.
I did too. And I just want to hand it over back to Elliot for any last BDI related comments. Elliot?
Well, I'd like to begin by affirming for you, Jeff, that it was very, very informative. I have come away with a much better and more detailed understanding of Kafka architecturally and from an implementation standpoint and a utility standpoint. So you and Sanjay, I thought, were a great 1-2 to cover that spectrum of perspectives on Confluent and Kafka. So thank you very much. From a BDI perspective, once again, we are reaching out to any and all who are interested in assisting the organization of BDI 2020. It'll be new, and what shape it'll take precisely, we're figuring that out. So we're looking for innovators in that space, and we invite you to join us. Thank you to Tuhin for doing an excellent job behind the scenes, managing the technology, which we're also experimenting with. But Tuhin is to be credited for this technology stack that we're using, the WebEx plus YouTube live streaming plus Slack, and Tuhin has put a lot of time actually over the past week in setting this up and experimenting with it. And so thank you for enabling this relatively seamless webinar, and I look forward to more like it in the future. That's all I have, Tuhin.
Okay, thank you everyone.
Yeah, thanks a lot, guys.
I hope that this was a little bit of something different to beat our cabin fever, if anybody's feeling that a little bit. And we'll try to do more on a monthly session as we try to be socially distant and virtually together. So thank you again. Thank you, everyone.
Yeah. Thank you very much for the support.
Thanks, everyone.
Thanks, everybody.
Bye-bye.
Bye.